Hello, everyone. Welcome to Cyber Smart Conversations with Harsha. I have with me Paul Mertes, CEO at Circuit Meter. Paul has more than 25 years of experience as an executive, directing the growth or turnaround of engineering, technology, and infrastructure companies. For the past 10 years, Paul has focused on the clean tech sector, with clients involved in the provision and control of clean energy into building and facilities. Great to have you. Thank you so much for joining.
It's a pleasure to be here.
So Paul, one of the questions I always like to start with is to share about the career path. I would love to hear more about you and your background.
Okay. I started out graduating from Waterloo with a degree in mechanical engineering and in what they call thermal fluids. I was always interested in energy, and I started out my career designing heating, ventilating, and air conditioning systems for a major consulting company in the commercial and in the industrial environment. It was in the 80s, and I was actually lucky enough to get some opportunities to do solar thermal system design and installation, as well as some energy software programs for NRC that got me into what was always sort of a passion, which was advanced energy, clean energy. I moved on from there, however, and did an MBA in finance. I was always wanting to get into the business side of things. And then I spent about 10 years in engineering management positions, developing in project management in things like environmental assessment, transportation systems, a lot of transportation system development, modeling of movement, modeling of revenue, public-private participation, things like high-speed rail, technology comparisons, evaluations, as well as the evaluation and the development of software systems to guide in the investment of railway maintenance operations. That was a nice lead-in into a move to CN to become a part of the management team that's doing turnaround on one of their subsidiaries, and I was responsible for turning around a number of businesses, including all of the technology products at CN, and that resulted in being president of a company that was responsible for remote controls, which was great Canadian technology. And my mission was basically to extend this into the United States, and we were quite successful in doing that. From there, I moved back into consulting, and I became executive in one of Ontario's major engineering companies, with operations in rail and transit and aviation, as well as in manufacturing and in energy, and got myself reacquainted into the energy side of things as more advanced energy, clean energy, wind systems were starting to come back into the environment. Not too long after that, I made my first move into the early stage sector, and I became CEO of a startup, and that was a geothermal energy company. I spent 4 or 5 years, including going through the big financial recession, just when we were raising money, which was a challenge to say the least. However, we were able to deal with all of those things, and we managed some pretty significant growth and some nice returns for the shareholders. And along the way, I developed a relationship with Tom Rand, who started the clean tech practice at Mars, and ultimately became a volunteer advisor to the clean tech sector at Mars, and got more knowledgeable about some of the advanced energy technologies that are coming to market. At the same time, Tom started what was then called the Mars Clean Tech Fund, that is now called Arcturn Ventures. And they invested in a company called Circuit Meter that had absolutely mind-blowing technology in the area of internet communications and electrical metering. And the Mars Clean Tech Fund invested in it, and Tom talked to me about expanding the management team. The founders were the technical geniuses behind the breakthroughs, and they wanted to add business experience as well as technical experience in taking these kind of control solutions into the commercial and industrial marketplace. And that sort of fit my passion, fit my areas of experience. And so I accepted. And since then, we've been basically charting the path from early stage startup to emerging company. And right now, we're just in the process of going to market for a Series A financing and hopefully taking this to companies to scale internationally.
What an incredible journey. So because you are so much into energy management, so today's discussion is about energy management and trends. Right. And you have been in this space for such a long time, and you have seen the real estate market has changed greatly from being very safe and easy to a very stable market. Now we are seeing it being a more volatile market. So what are the challenges of the real estate market that you are seeing in terms of energy management?
Well, there is one big challenge, which I feel is hopefully transitory, and that's just how the entire real estate market is dealing with COVID, because they've had over the last year and a half, they've had big declines in tenancy, and that impacts on their revenue and their projected revenues, et cetera. But leaving all that aside and assuming that all those things are going to come back, I think about the signs that they are. I think the traditional issue in this sector with respect to energy management is that it wasn't ever considered to be the highest priority. There were all sorts of other things, including keeping the tenants happy, that just constituted larger percentages of the cost function and of what was really driving the business. And so that made it difficult to get a focus on energy management, that is. That being said, as a member of the engineering profession, I think all along the profession has and the industry has continued to make advancements in energy efficiency, go back to the 70s or even earlier. But there's always been ongoing developments in chiller technology, refrigerant technology, controls technology, variable speed drives, better windows, better understanding of air. I mean, all of these things have continued to improve. But I think that the focus now on climate change, which is driving a much more rapid acceleration towards net zero or near net zero operations, combined with the need to report on this and show what you're doing to optimize your energy consumption or minimize your energy consumption or optimize your efficiency. These are causing changes. The other thing that's enabling change is in fact, some of the things that surround our technology, which is advanced communications to the cloud, cloud computing software, and the ability to do a lot more with information at a much lower cost. So, sort of to summarize your question, I think before the costs weren't considered to be significant compared with some of the other priorities of the day. But the drive towards climate change is really bringing net zero targets up to the forefront. Companies are having to start to think about accounting for what they call scope 3 carbon footprints. And cities like New York are passing laws saying you must sub-meter, you must benchmark, and you have to be able to account for exactly what the energy use of your building is, and all of these things are putting pressure on the industry to change.
Yes, and recently I was talking to one of the energy management, an energy manager, and he mentioned that energy management is becoming a new way of attracting new tenants. Like you can generate more business, granted energy saving, advanced control, and even detailed analysis to make better decisions. And we'll come to that when we'll talk about predictive analysis. You mentioned about cloud, moving data to cloud and these cloud platforms. And we are seeing Internet of Things, IoT sensors, and these energy management platforms are coming in.
Yes.
How do you see they are changing how energy and facility managers talk about energy efficiency?
Well, I mean, again, back to sort of the way things were done traditionally, if you're sticking with the commercial real estate market, in larger buildings in particular, some of the most where they can afford the more advanced systems, they're all very locally oriented. So they have what they call building automation systems, which use um, um, data control protocols like Modbus and BACnet. It's all built around the operation of the system, and it's all sort of confined to the building. And it's all about optimizing energy, basically from a thermal energy perspective. And that means minimizing the amount of gas used to heat, minimizing the amount of electricity you use to cool, and that translates into minimizing the amount of outside air, because heating or cooling outside air uses up energy, etc. A lot of that is changing, but also management of the buildings themselves is changing, because we want to compare one building to another, because the management of buildings is being done corporately at a portfolio level. And it would be, I think it's becoming clear that it would be good and beneficial to be able to compare the performance of one building to another, but also to be able to compare the performance of each piece of equipment in the building. And building automation systems are really about how the piece of equipment is operating. Well, what's the RPMs? How many CFM are they blowing? What are the temperatures? They don't actually measure how much energy each pump, each fan, or other equipment, which really isn't even part of the HVAC system, like elevators and lighting and things like that. So as we get into this new technology that can measure everything, and you can do it building to building, what you really need to do is you need to bring it all together. And obviously that can't be in any one building, it's got to be in the cloud. And obviously we have to do it economically. So getting all this data up to the cloud and putting it into a single piece of integrated software, not having to negotiate and continually designing patches and interfaces and things like that, means you have to have a platform that's both very functional and efficient, as well as effective at merging data and generating fast user time, so that you can ask a question and have a response back instantly, as opposed to in hours.
Yes, and it's a way to provide the holistic solution. Like you'll have these the overall view of the entire portfolio, how it's performing.
That's right.
And now it's tied to technology. So to get this, we are putting more and more technology in a building. So in a way, increasing the attack surface of a building. So what are the security considerations made to ensure when you put a solution in a building, it is protected from cyber threat?
Well, for the interest of time, and also because I have my own perspective on it, I'll just talk about circuit meter, because that is one of the areas that we bring a really significant advantage to the marketplace. Our technology was designed, fundamental architecture was unique, actually, in that what the way our meters are designed is we have the web communication electronics in our meter, and all you have to do is plug a local Ethernet cable into the bottom of it, and we push the data to the internet. And because we're pushing it to the internet in an encrypted way, it's always going out, and there's literally no way for someone to use our interface, even though we don't require the host system, even though we're using it, to open any ports. It's a send only, almost a little caveat in there. We do have a unique way of connecting to our meters that is beyond the scope of this conversation, and it's one of our IP secrets. But we can update our meters and update our firmware, and we can get information out of it. But essentially, all of our meters, it could be hundreds of meters or thousands of meters, all operate independently. Basically, just send the data to the cloud. So there's no way in, and it's cyber secure. And that's turning out, and in the future, I think even be more recognized as a critical feature, as more and more managers want to get beyond having local systems and want to get their information into the cloud. They don't want to your point, introduce a security a hole in the firewall.
Yeah, and this is interesting to know. So now coming back to the core business objectives that we started this for. So reducing energy demand and cost.
Mhm.
And the core business objectives remain the same. A, reduce energy demand. B, save cost.
Right.
But what we have seen is these strategies and tools for achieving these objectives are rapidly changing. Like AI solutions, predictive analysis, we have sensors that collect data, we have trends, we are seeing and we are measuring the success of the program. So what in your opinion, and what we have seen in the industry, how these AI solutions, predictive analysis can improve management methods and save money?
Well, I'll answer that question in just a second, but I think it's important to take one step backward. You just talk about what the real-time circuit or equipment level data itself can do. And that's emerging now in various places in the States, like New York, for instance. They call it real-time energy management.
Mm-hmm.
And it's being subsidized there. In Washington, they've got a different name for it. We call it forensic energy management. But the point is actually very, very simple. And it's just based on industrial engineering principles, which are to set standards for every machine, benchmarks, and then have real-time notification if those benchmarks are exceeded. So you can identify when equipment should be working and when it should be idle, and how much energy it should be using, and what an acceptable threshold is, and above which you could say there's something going on, the machine is deteriorating its performance or it's failing, etc. And that's a key link to the answer to your question about AI. But we can do all that with Circuit Meter. We enable forensic energy management, etc. And once you put this into a building and you get rid of all the initial things that you find through a virtual energy audit, you can move into what's called sort of a continuous energy audit, where you've eliminated timing issues, you've found all the things that are using energy at a time when they're not supposed to be, etc. So now you're into continuous energy audit, and this is where AI and machine learning, etc., come into play. Because when you do the way we do it, anyways, we're measuring or sampling voltage at 200,000 samples per second. It's very, very, very granular, and so we can detect issues in harmonics and all sorts of things in the performance of an electric motor, for instance, that over time, the engineers believe can be used to detect real-time deterioration, whether it's a fast deterioration or a slow deterioration. This kind of impending malfunction or imminent malfunction can be detected through AI techniques. So they need a system like ours to generate the data, but it's our vision that we'll be participating with all sorts of different developers of AI software that need the data, but then the science is going to go in all sorts of different directions, and Lord only knows where it'll all end up. But it's very exciting because there's an awful lot of technical possibilities with the end objective basically being you design a net zero building, or you fix up and retrofit a building to be very energy efficient. And then you use these advanced monitoring and then these AI software systems to anticipate when something is going to go wrong. And could be so sophisticated, it'll be back to what we were doing 30 years ago as we were developing railroad. We'd say, there's an impending failure in this motor, but we can go for another 200 to 300 hours before it makes economic sense. So we should schedule something in, either have a maintenance or have a replacement or anything like that. But the idea is that with this software and the science, that we can basically move our entire building stock, whether it's commercial buildings or even high density residential buildings, to a state of optimum performance.
Yes, and these insights not only help in optimizing the performance, save cost, but also reduce the downtime of the equipment. Plus, has a great impact on the life of the equipment.
Absolutely, and that provides value in other areas. For instance, the cost of an unscheduled breakdown in
Yeah.
some places, more in industrial processes perhaps than in the commercial area, but breakdowns in industry, can be hugely costly in comparison with the cost of good maintenance. And and that sort of brings me to a very high level number. If you add up all of the energy used in Canada and the United States and take out houses, so basically commercial plus high density residential and industrial, it's estimated right now we waste $80 billion a year. So implementing these technologies, putting in new ways of doing things, developing these solutions can save a lot of money and actually be profitable for the people who bring it to market, as well as be very beneficial to the owners and managers of the commercial real estate as they bring their own costs down.
Absolutely. And thank you, Paul. Thank you for sharing these insights.
My pleasure.